Consider a two-terminal linear network. A two-terminal linear network. So usually they will have two ports, port 1 and port 2. Let the variables for port 1 be I1 and V1, and similarly for port 2, I2 and V2. So which means you can write the two of the variables as dependent variables. So if suppose V1 and I2 are the dependent variables, they can be written as function in terms of I1 and V2. So which means V1 is nothing but H11 I1 plus H12 V2, and I2 is H21 I1 plus H22 V2. So how H11 is V1 is 1 and I1's 1 is H11. Similarly H12 is V1's 1 and V2 2. Similarly H21 2 from I2 and 1 from I1 forms H21, and for H22 2 from I2 and 2 from V2 form H22. So you can write H11 as V1 over I1 when in your first equation you equate V2 to 0. And similarly H12 will be V1 by V2 when I1 is 0. From the second equation you can find H21 is I2 over I1 when when V2 is equal to 0, and H22 will be I2 over V2 when I1 is 0. As per IEEE norms, this H11 is written as HI, which is nothing but impedance. Impedance is voltage over current, so it is HI. H12 is, you find it's a ratio of voltages, and the way the voltage gain is, it's input over output, so it's a reverse gain, so it's denoted by HR. And H21 will be I2 over I1, so this is also a ratio, and you find the current is output current over input current, so this is a forward current gain. And H22 is I2 over V2. I by V is admittance, so it is HO. And so using these norms, we will now look at how to configure for the transistor. So the H parameter equivalent circuit, the way you can write using the equations is, you will have a HI with the current of I1, and you have HR V2. So what's your first equation? Our first equation is V1 is equal to HI I1 plus HR V2, and I2 is equal to HF I1 plus HO V2. So this is what we are going to represent it in the equation, in the equivalent circuit. So the next one, for the second port, it is a current gain. So current gain, you will denote it with the arrow symbol. So this will be HF I1, and we have a H0. H0 will come in parallel, so H0. So this will be your output V2, and this will be our input V1. So if you consider a common emitter configuration, our I1 will be base current and I2 will be the collector current, because common emitter is grounded. And similarly V1 will be VB, it's VBE, which is denoted as VB, and V2 will be VCE, which is denoted as VC. So now our equations will become VB is equal to HI into IB plus HR into VC, and IC will be HFIB plus H0 VC. So this is the case for a common emitter configuration. Similarly, you can write it for common base and common collector. So our HI will be VB by IB when VC is 0. HR will be VB by VC when IB is 0. HF will be IC by IB when VC is 0, and H0 will be IC by VC when IB is 0. Now for each of the parameter, we need for each of the configuration of the transistor, we need to find different parameters using these H parameter values. So the first one will be current gain. Current gain will be represented by AI, which will be output current by input current, I2 by I1. So in your H parameter configuration, representation circuit, you can connect in a load impedance, and you can have a input voltage and a source resistance. So this will be your two-port configuration. So if suppose I connect in a load and a voltage source and a series resistance, and we are supposed to calculate it, means then this will be the I2 current, this is your I1 current. Because of this load, you will have a IL current. So this IL and this I2, they are going in opposite directions. So the way the load circuit will be balanced is your I2 will be equal to minus IL. So current gain is minus IL by I1. So it is minus I2 by I1. But from equation we know that I2 is equal to HF I1 plus H0 into V2. And but our V2 will be output current into output impedance. So we will substitute 3 in 2 first. We will get I2 is equal to HF I1 plus H0 IL into ZL. IL is minus I2. So if we move the equation to the other side, I2 into 1 plus H0 ZL will be HF I1. So I2 over I1 is HF divided by 1 plus H0 ZL, or your current gain is minus HF divided by 1 plus H0 into ZL. The next parameter is input impedance Zi. Input impedance is nothing but V1 by I1, and our V1 equation is V1 is equal to Hi into I1 plus Hr into V2. So V1 by I1 will be, if you divide this equation by I1, Hi plus Hr into V2 by I1. But we know that V2 is equal to minus I2 into ZL. So Zi will be substituting for V2 in this equation, Hi plus hi minus hr into I2 into ZL by I1. I2 by I1 is current gain. So ZL will be HI plus HR ZL into AI. So either you can stop it with this, or you can substitute for AI, which is minus HF by 1 plus H0 into ZL. You substitute this in this one, then you will get ZI as HI minus HR HF divided by 1 plus H0 ZL into ZL. So this will be HI minus HR HF divided by H0 plus 1 by ZL. 1 by impedance is admittance, so this will be H0 plus YL. So this is how you will calculate or determine the input impedance given your H parameters. The third one is voltage gain. Voltage gain is given by AV, which is nothing but V2 by V1. V2 is minus I2 into ZL. So in terms of current gain, you can also write this as AI into I1 into ZL. So V2 by V1 will be AI into ZL into I1 by V1. I1 by V1 is ZI. So your voltage gain is current gain into load impedance by input impedance. So if you look at voltage gain is ratio of the voltages V2 by V1. So V2 is nothing but minus I2 into ZL. The V2 is actually IL into ZL. IL is in opposite of I2. So instead of IL it is minus I2 into ZL. So this I2 is nothing but minus I2 by I1 is current gain. So substituting this in this one, we will get AI into I1 into ZL instead of I2. So voltage gain is V2 by V1. V2 by V1 is nothing but this whole equation divided by V1. So AI into ZL into I1 by V1. I1 by V1 is nothing but input impedance. So AV is AI into ZL by ZI. The last one is output admittance. Admittance is being on the output side, I2 by V2. So we will consider the second equation of the hybrid parameter. I2 is equal to HF I1 plus H0 V2. So dividing by V2, we will get I2 by V2 is equal to HF I1 by V2 plus H0. Now consider on the input port side, if suppose you are not giving any input voltage, then you can balance your circuit such that Rs into I1 plus Hi into I1 plus HR into V2 will be equal to 0, or I1 into Rs plus Hi plus HR V2 is equal to 0. So I1 by V2 will be equal to minus of V2 divided by Rs plus Hi. So if I substitute this in the first equation, then I will get Y0 is equal to I2 by V2, which is H0 minus, so instead of this term we are going to substitute it with this, minus HF V2 divided by Rs plus Hi. Sorry, this is not V2, this is HR. So if I substitute in this equation becomes Y0 is equal to H0 minus HF into HR divided by Rs plus Hi. So this will be your equation for the output admittance. So you can calculate all of these four parameters: the current gain, input impedance, voltage gain and output admittance once you know the values of the H parameters for any of the given transistors.